Hey everyone, welcome to today's Explainer. We're looking at June 22nd, which is honestly one of the greatest dates in all of math history, and we're going to show you exactly why. June 22nd. On this exact day, stretching across different centuries and totally different countries, brilliant minds were busy changing the world we live in today. Let's dive right in and meet them. Here is the timeline we'll be jumping across: 1852, 1864, 1910, and 1925. We're going to treat this history like a detective story. We won't get bogged down in the heavy math itself, but instead we'll look at the incredible ways these discoveries literally shape our modern lives. We're starting our journey with a real-life wonder. Have you ever actually stopped to wonder how search engines instantly organize and filter millions, no, billions of web pages in a fraction of a second without even breaking a sweat? It's this colossal task that happens so fast, we just take it completely for granted. Well, the answer goes all the way back to June 22nd, 1852, and a brilliant Czech mathematician named Eduard Weyr. Fast forward a bit in his life to 1885, he discovered the Weyr canonical form for square matrices. Basically, he created a groundbreaking way to organize and simplify really complex linear algebra. Instead of just a chaotic jumble of numbers, he figured out how to arrange data into predictable matrices. And here's the kicker. Today, we use these exact matrix principles to help our massive data systems rank, sort, and deliver endless information instantly. It's like the entire internet is organized by invisible grids of math. Every single time you hit search, you're relying on this invisible grid drawn up way back in the 19th century. Pretty wild, right? Okay, still on June 22nd, we're going to jump forward just a few years to 1864. Same date, completely different country, and an even bigger idea. Think about your smartphone for a second. How does your GPS instantly find the absolute fastest route, pinpointing your exact location anywhere on Earth? Whether you're driving through a super dense city or hiking some remote trail, that little blue dot always knows exactly where you are. The secret behind your favorite navigation app actually begins with Hermann Minkowski, who was born on this exact day in 1864. Minkowski did something incredible. He coupled space and time together into a single four-dimensional continuum. This was the mathematical framework that Albert Einstein later used to develop his general theory of relativity. And because of this exact physics framework, our modern GPS satellites can perfectly synchronize their clocks with the Earth. See, time actually moves slightly differently for satellites zipping around up in orbit compared to us down on the ground. Minkowski's math corrects that drift. Without it, our navigation apps would be completely lost. So, the crucial takeaway here is that your phone's GPS is navigating through a four-dimensional space-time continuum. It's not just a map. You are literally holding a profound piece of astrophysics right in your pocket. One day, so many stories. Let's keep moving forward along our timeline to the year 1910. Look at the screen you're watching this on right now. Did you ever notice how it responds instantly to your touch? How do our devices actually process millions of commands flawlessly to run your favorite apps? Behind that sleek glass, there's a staggering amount of processing happening in the blink of an eye. To solve that mystery, we turn to Konrad Zuse, born on this remarkable day in 1910. Zuse actually built the very first programmable binary computer called the Z1, right in his parents' living room. He used binary logic, a system of mechanical switches representing simple zeros and ones, to process complex commands. It sounds super basic, but we rely on this exact same binary logic today. By simply turning switches on and off in massive complex patterns, his invention became the absolute foundation of every digital screen, computer, and smart device we use. It's incredible how simple it all is at its core. Every app on your phone is secretly just zeros and ones dancing together. All the crazy complexity of our digital age boils down to that one elegant binary rhythm. All right, we have one final jump to make on our June 22nd timeline. We've seen a lot of births today, but now we're moving to a monumental passing in the year 1925. Have you ever noticed how seamlessly CGI and video game graphics shift, scale, and rotate when you move your character around a virtual world? Creating a believable, immersive 3D environment in real time requires calculating millions of constantly shifting angles. It's a massive undertaking. Well, the math that makes all those immersive graphics possible belongs to Felix Klein, who passed away on this exact date.
In 1872, he published the Erlanger program, and it completely revolutionized geometry. He unified different types of geometry and showed how the properties of a space remain invariant or unchanged under specific groups of transformations, meaning a digital square stays a square, whether you shrink it, spin it, or look at it from above. Today, our modern graphics cards use this exact geometric math to seamlessly scale, move, and rotate 3D objects in real time. It's how we navigate digital worlds without everything just warping out of shape.
It's truly fascinating to think about. Every 3D video game world is literally built on the geometry of transformations. Klein was mapping out the mathematical rules for virtual reality long before the very first screen was ever even turned on. Looking back at our full timeline now, 1852, 1864, 1910, and 1925, we can really see how this one single date connects so many brilliant minds across different eras. It's a day that quietly laid the groundwork for the modern age. Every person we met today asked the exact same question: what is the pattern hiding inside the chaos? And because they asked that question, our modern world is now filled with GPS, the internet, and digital computing. So what patterns will you find in